Selamat sejahtera and good morning to panelists. My name is Ng Sizik and my match number is AM170201. Today I'm going to present my poster of my final year project, and the title is Evaluation of High Density Polyethylene Plastic Bag Performance Towards Edge and Point Stresses Using Taguchi method. So let's start with the abstract. As we know, plastic bags are very useful because it's low cost and convenience for packaging the items. And the reason why I carry this study because the problems with the strength of the plastic bag tends to tear easily and perforate. The objective of this study is to validate the simulation result of HDPE plastic towards HDPE plastic bags manufactured in UTHM, and also wants to evaluate the performance of plastic bag towards mesh, edge, and point stresses by using finite element analysis and Taguchi method. The simulation of 10 task tests was conducted using SolidWorks 2017 to validate the HDPE plastic material properties by comparing with the 10,000 tests that already done by the seniors with STS test. Also, the Taguchi method was used to arrange the parameters for the edge and point stresses test with variety of mass, angle, length, and distance between the point loads. For the result of validation of HDPE plastic material properties, the result shows that the percentage of error for all loads were lower than 10% after compare the simulation result and the tensile test result. And also for the result of simulation, validation of simulation test, the result shows that the percentage of error was lower than 5% by comparing the real-life application result and the simulation result. For mass stress test, the loads with 5 kg square bags have the highest stress added on the surface of plastic film, which is 22.399 MPa. For edge stress test, the sample deal with 1 kg, 20 degrees of angles, 20 mm of edge length have the highest maximum stress and displacement added on the surface of plastic film, which are 34.086 MPa and 84.94 mm. For point stress test, the sample deal with 1 kg, 10 degrees of angles, and 30 mm of distance between the pointers has the highest maximum stress and displacement, which are 50.676 MPa and 63.64 mm. And I found that both sample D and G was perforated because the maximum stress added on the plastic film was exceed the tensile stress of HDPE plastic, which is 28.4 MPa. From the result of 10, I can say that the objective of this study was achieved. So continue to the introduction. We know that plastic bag is a popular item that used for carry, transport, and packaging the stuff because it is lightweight and hygiene way of transporting. Besides, improper disposal and tremendous use of plastic bag can damage to the ecosystem and natural environment. However, there are two strategies to reduce the impact to the environment in Malaysia, which are no plastic bag day programs and recycling the existing plastic product. Also, Wada Plastic Industries Study Berhad is the company that has the problem with the strength of the plastic bag, and this company is manufacture various types of plastic bag. For example, HDPE, LDPE, and recycled plastic bag. So, continue to the literature. Usage of plastic bag in Malaysia. A study found that there are 18,000 metric tons of plastic produced a day, and which represent 24% of overall dairy national outputs. And in Penang, there are 1,500 to 1,700 tons of plastic waste every day, and it can be said that every person has to dispose 1 kg of plastic waste every day. Environmental impact of plastic bag. A study on 38 green testers found that there are 61% of green testers has injected the marine debris, such as plastic bags, loops, and clothes. This marine debris can restrict to an enhanced animal's movement, and the animal will get infection from deep wounds by this marine debris. Finite element analysis. The studies wants to determine the force and the pressure that added on the wall of the plastic bag for algae growth using finite element analysis. And at the end of the study, the maximum stress and the displacement of plastic bag are evaluated. The Taguchi method with the simulation of orthogonal metal casting using Taguchi method. Before start the simulation, This study will arrange all the contour factor and the levels by using Taguchi method, and the L8 orthogonal array will be selected before they run the simulation, and then use these parameters for the simulation. So continue to the methodology. And this one is the flowchart of the project. The first, we need to identify the problem with the strength of the plastic bag because it can influence the performance of the plastic bag. And identify the material used for the simulation, which is the HDPE plastic. After that, compare the tensile strength of simulation result and the MTS test that already done by the seniors. After the material properties were verified, I need to compare the real-life application result with the simulation result. If the simulation result was verified, I will arrange the parameters by using the Taguchi method and run the simulation. After that, I have get the simulation result, I will do the analysis and the discussion. Last but not least, I will do all this result will report to the WADA Plastic Intrinsic Study. There are 4 parameter study. The first one is validation of HDPE plastic material properties. The loads applied was set as 15 newtons, 17 newtons, 19 newtons, and 22 newtons. The reason why I set this parameter is actually the first time I run the simulation and I get the result is not very realistic and not very good. After I discussion with my supervisor, we found that it might be the problem with the material properties that I use might be something wrong, and then we try to change to another senior's data, and then we get the material probabilities from his study, and then we need to verify the material probability first before run other simulation. And the second one is the validation of simulation result. The rules will be different mass and the different shape of the base will be used in the experiment, real life experiment. And for the simulation, also I will construct the same model, same CAD model, just like the real life load I have used. For the third one is the simulation of stress test. There are 3 different factors was used, which are mass, angle, and the length. And each factor has 2 levels. The reason why this parameter will be set like this because it's related to the fish fin, which is the dorsal fin, because people found that the fish fin always pierce the plastic bag and make it tears. And the last one is the simulation of point stress test. There are also 3 different factors was used, which are mass, angle, and distance between the point loads. And also, each factor have 2 levels. And the reason why I set this parameter because it's related to the fish tail and the distance between the fish mouth. Because when we fill our fish vertically into the plastic bag, it will cause a force acting on the bottom of the plastic bag. So continue to the result and discussion. The first one is validation of HDPE plastic material properties. As we can see, the table below shows the experimental result of previous study compared with the simulation result. And we can notice that when the load applied was higher, the displacement of the plastic bag will be longer. And at the maximum load applied was 22 newtons, and the displacement of plastic bag for the experiment was 90.26 millimeters, and for the simulation is 87.27. It's about 3 mm of error, and the percentage of error was 3.31. And the figure at the right side is show the simulation result for the loads with 22 newtons applied. So the second one is the validation of simulation result. This is the comparison between the real-life application result and the simulation result. And we can see that when the mass of the loads increase, the displacement of the plastic also will be increased. And there are 2 same mass but different share of base, which are 5 kg of square base and 5 kg cylinder base. But 5 kg of cylinder base have larger displacement compared to the 5 kg square base in this test. And the figure below shows is the real-life application test and the simulation test. And also the mass test also will be carried out with determine the maximum stress on the surface of plastic film, and the load applied will the same as the second test. And I found that the 5 kg loads with 5 kg square base have the highest maximum stress on the surface of plastic film, which is 22.399. The reason why the those with 5 kg square base have a larger stress compared to the 5 kg of cylinder base because the square base there are 4 sharp points on every corner at the bottom of the base, so it will create a larger stress compared to the cylinder base. And the figure is the result for the simulation of 5 kg square base. And the fourth one is the simulation of edge stress test. From the table, I can notice that the sample D have the highest maximum stress at displacement, which are 34.086 megapascal and 84.94 millimeters. And sample D was perforated because the maximum stress at on the plastic film was exceed the tensile strength of the HDPE plastic, which is 28.4 megapascal, while for the sample A, B, and C was not perforated. And we can notice that when the mass of the loose increase, the stress acting on the surface of plastic film also will be increased. But for the control factor of angles and the edge length, it cannot determine directly from the result because it also need to consider other factors. By comparing these 3 factors, I can say that the mass of the loose, the control factor of mass of the loose are more significant factor, followed by the edge length and edge angle. The reason why the edge length is more significant factor compared to the edge angle because the sample D have larger angle with smaller edge length, but it create larger stress, although the sample C have smaller angles. And the simulation results for sample D will show at the right side. And the last result that I need to discuss is the simulation of point stress test. And I can notice that the sample G have the highest maximum stress and displacement, which are 50.676 megapascal and 63.64 millimeters. And the sample G and sample H was perforated because it's already exceed the tensile strength of the HDPE plastic, which 28.4 megapascal. And for the sample E and sample F was not perforated. And I also observed that the point load at the left side and the right side have larger stress compared to the middle one. And also the diameter of hole that perforate by the sample G and the sample H also will affect by the angles of loose, because the larger the angle of loose, it will tend to match the larger the diameter of the hole will be perforated. And for this one, by comparing these 3 control factors, the stem, the mass was more significant factors, followed by the angle of point loss and distance between the point loss. In conclusion, the validity of simulation of HDPE plastic material properties was proven, and the performance of plastic bag towards mass, edge, and point stresses was successfully evaluated by using FEA and Taguchi method. And also there are some recommendations for the further research, which the first one is the larger size of orthogonal array can be used for the control factors and the labels, because we can determine whether which factor are more significant that can directly affect the stress on the surface of plastic film. And the second one is to change the material used for the simulation. For example, LDPE, recycled PET, PP, and other mixing plastic material with dehydrating additive. That's all for my presentation. Thank you.